Well, as you can see from the title, I'll be presenting this takeaway on whether you can or should hold your own smartwatch. Now, the idea is fairly simple. I mean, who wouldn't want to do this? You could add endless possible features that would only be limited by your own skills. And while that's not technically true, we'll get back to that. You would also have complete control of your data, considering all of the personal information they capture these days, including biometrics and messages and all of that. It could also end up cheaper than an off-the-shelf solution. So the first step, of course, is to build the device. And for that, we need some kind of controller, a screen, a housing to put it in, a band to attach it to your wrist, and a battery to power it. For the controller, I went with a Waveshare ESP32, which has an integrated touchscreen, simplifying the process quite a bit. Now for the housing, I elected to 3D print housing. I have some experience with 3D modeling, so I used an awesome tool called FreeCAD and the available diagrams to design some different housings. It went through quite a few iterations. Shown here is one where it has like an external battery holder because it ended up being quite thick. As you can see here, you can see the final case as well as the band that I attached to it. I ended up using an existing band from a watch that I had. Then for the battery, the nice thing about the controller I went with, it has an integrated battery connector and charge controller. However, unfortunately, I wasn't able to find a battery with the correct connector. So I ended up having to solder it directly onto the contacts, which let's just say my soldering isn't the best in the world, so I will not be showing pictures of that. The next stage is to have some kind of firmware to run on it. And for that, I use a really cool library called LVGL, or Light and Versatile Graphics Library. This is specifically designed for embedded controllers like this. As you can see here, some sample code from their website where you can define buttons or other widgets with lots of different options for them. And then you can define event handlers that automatically get called. It manages a lot of the states for you, which is quite helpful. It also has a lot of features in terms of animations and tile views, so you can easily iterate and add more screens to your project. Here's just some more code. I'm not a big fan of the Arduino IDE, but fortunately you don't have to use it directly. I just use it to upload the code. Here's a quick demo of the tile view. So all of these animations and so on are built into LVGL, so I don't have to set up any of this myself. You just define what you want on a page and it'll handle the transitions and the touch controls for you. I ended up with these 4 faces, or screens rather. Of course, time, very important. It has a battery indicator, but don't pay too much attention to that because it's definitely correct. Then some basic settings, turning the Wi-Fi on and off, syncing the time, and a brightness slider. I also added functionality to connect to different Wi-Fi networks, so I didn't have to hard code a specific network I wanted to connect to. And this is all persistent throughout restarts or the battery getting flat. It'll remember the last Wi-Fi network. I also added a weather page, and I learned a bit of a lesson in reading the API docs. As you can see here, we've got minimum current and maximum temperature, as well as some other measurements. And what I didn't realize is that for the free API, this doesn't actually refer to minimum maximum for the day. Just if you're in a large city, it'll tell you, oh, the coldest part is this and the hottest part is that, but it should be an average of the current, which I think is a bit misleading. Although I was very confused why they were always very similar. I did run into quite a few challenges though. The LVGL documentation, while very well set up, is quite out of date as it's constantly being iterated on. So whenever you're using their samples, you kind of have to figure out what's changed and change it accordingly. Then I ran into a lot of issues trying to implement Bluetooth low energy notification syncing from your phone, but I'll come back to that. Then unfortunately, the serial communication was not working on my unit. So while I could flash the firmware, I couldn't debug it very well and had to add like debug labels in every screen. And yeah, it was very annoying. Some hard limitations I ran into with doing this as a DIY project was the chief one, I think, is battery life. At the end of the day, you're just not going to beat a whole team with circuit board design and lots of experience with software. So I ended up with about 2 hours of battery life on average for my device, which is not ideal for a watch, but it's a cool proof of concept. The ESP32 does have some cool power states, but unfortunately, they interfered with the touchscreen functionality. So once it went to sleep, it refused to wake up, like me in the mornings. Then with the BLE notification syncing, you really need an app on your phone to send this information to your watch. And I didn't have quite the time or the available effort to do that. And while there are some generic apps available, they require pretty invasive permissions in order to function. And I just wasn't too happy about giving them those. There is a cool alternative, though. I came across this app, which is called Chronos. It's developed by a man called Felix Piego, who I think is based in Kenya. And he has quite a very well set up app, as well as firmware for specifically my ESP32. That then does all the syncing, the time syncing, notifications, everything from your phone instead of using Wi-Fi. I was able to flash the firmware, get the app and everything. However, I ran into issues connecting the app with the watch, so I wasn't able to get that working. But for other people who want to do a similar project, this might be a cool way to get started if you're able to get it working. Now, something I mentioned at the start is the cost. The controller, screen, everything was about 500, which is not too bad, all considering. And then 3D printing, pretty cheap. This, of course, does not include the 3D printer, which I conveniently already had. Battery is about 70 Rand, and the band I just stole, as I said, from a different watch. I think the real problem, though, is if you factor in how much time you need to spend on this. So software development, about 200 Rand an hour. 3D modeling is very similar in terms of pricing. So anytime you're spending about 30 hours on this project, you could buy a very nice smartwatch for the amount of time you're sinking into this if you would just spend that time working, which I did. I did this in my own time, don't worry. So yeah, I think at the end of the day, whether you should is really up to you why you're doing it. I think there are lots of reasons to do it, for the fun, for learning about microcontrollers and maybe some 3D printing, so even some hardware things. There's also the upfront cost is not very high. I think that this is something that a lot of people can benefit from. Some reasons not to, however, is if you don't have all the extra time in order to implement the features that you want or need from such a device. You might also want something that just works. And this is not the project for having something that works. It's a project for having something that you can show people, hey, look, I'm doing this. And when I ask you, oh, can it tell the time? You're like, sometimes. Troubleshooting can also be frustrating, especially when you're running into those documentation issues, or as in my case, when I couldn't debug properly. But at the end of the day, I think that it was a great project, and I would recommend to anybody who's interested in learning about these things that it's a great way to get started.